Hey guys, it's Vince. Today in this video, we're going to be doing a direct comparison between a G540 Master Edition enclosure system that I've built custom for a client, and I want you to see the comparison to what's being offered elsewhere in terms of not only quality, but also looking at used systems, because these come up all the time as far as budget. So this part of the video, we're going to cover this system, and then we'll look at what's being offered at some really ridiculously low price margins. But again, the argument is always that they're using the same components. Okay, so we've got the G540 here, Master Edition enclosure. If you're not familiar with it, allows for all of the options the G540 supports. So these GX16 3-pin ports are designed for your switches or your touch plate. Why are they using 3-pin? 2 of the pins would be allocated to your switch. The 3rd pin is always allocated to your ground for your shield drain. And the ground will be inside the enclosure with the ground bus. Again, we have 4 of these installed. On this side, we also have an additional 3-pin, which would be installed to support one of the outputs on the G540. Now, this particular client wanted to have spindle control on his G540 for his business. You see one 6-pin connector being used. Now, why am I using a 6-pin connector? Because while I'm using a GX16 6-pin male connector here, it allows the end user to utilize one cable to supply all of the required connections from the G540, including the shield drain, which must be ground drained inside the enclosure, as far as speed manipulation and also cycling on and off the spindle. That keeps everything much smaller, much neater, and again, consolidates the size of the enclosure having to be used, and also allows maximum expansion inside the box, once again, keeping everything in a much neater format. What we see here with all the graphics, I do all of my own graphics myself. And again, these are all my own substrates. I also own a graphic design business, and you can see here, we've got the GX16 wiring pattern. And then underneath here, we have the VFD interface cable, which I include with my system, made out of my DS Flexion cable. I'll cover that in a minute. But if this client ever has to service, or for that matter, even connect his cable to his VFD, he has all of the connections right here. That is the whole idea of this, is that I empower my end users, that they're not liable for every second, hey, how do I do this? The idea is for you guys to learn. And how do we learn? We implement using proper documentation so that you can do this yourself. This particular system is built to support pneumatics, which again, it is. Now I'm going to show you the cable, I'm going to show you the cable that was built, and this is the GX16 6-pin. It's on a piece of DS Flexion 20-foot, 20-gauge 5-lead. Okay, you can see it right here. And you can see how this is set. All of these ferrules are not only crimped but soldered on. You can see on the ends, they're all perfectly soldered on. Okay, this has its shield drain attached to the 6th pin. This connector has been properly machined out in order to fit this cable, and you can see it fits like a glove. All this end user has to do is plug this in. It will be properly shield drained to the base of the power supply's chassis, which again is of course grounded. And the system's done. He just then connects his end leads following the wiring diagram on the actual enclosure, and he's set to go to connect to his VFD. I will then supply the documented email so he'll know exactly how to wire the actual VFD and program it, and he's ready to go to town. Okay, but let's take a deeper look, right? Let's look and see what the difference is. And of course, just so everybody knows, I want to cover this real brief. DS Flexion cable is rated to 10 million flex cycles. This is ultra flex cable. Okay? This is the real deal, guys. Okay? This cable alone, if you were to buy this through IGUS, I've discussed this many times, you're looking easily at about $8, $9 a foot. Okay? He's got 20 feet here. You can see how his leads are done as far as length. That's all done with the proper boot, and this is a double wall heat shrink boot. This produces the most durability, and again, adhesive is used here so it doesn't slide. This is all set. Let's come in and look at the chassis. Okay. First, we've got our relay, and we've got our 48 volt, 30 amp relay with servicing diagram right here. When I say servicing diagram, it does not get any easier than this. everything is correctly allocated to the coloring of the wires being used on the physical relay. Pin 1 is blue lead. Pin 2 is GX16, which of course we can see the black lead right here. And then we have the white lead for the G540, and we have the red lead for the 48 volt coming in from our power supply. What you see with these little nodules on this white lead going to the G540, which is the signal cable, is ferrites. So again, we don't have to use double shielded cable because he has ferrites installed all the way through the length of this cable going back to the drive. It's then toollessly mounted with thumb nuts to allow for simple servicing. If he had to change a relay out due to a failure, he could change this out in seconds. Okay, you can see these right here. They're just thumb installed as far as finger tight, and you're good to go. We also have over here a ground bus. Look at the labeling. The ground bus, and we can see the shield drain coming in from a GX16 to support the VFD cable, is already connected. We have full continuity on the chassis, been validated. And guys, just so you know, when I say it's validated, here's my tool. The same tool used by NASA, a Fluke 179 multimeter. Okay, I get guys that'll show in their videos, they like to use different types of multimeters, and they say, oh, it really doesn't matter, this and that. To me, it's a definition of my craft. Okay, if I'm willing to invest that kind of money, it should define what length I'm going to indeed design this system. Okay, so we didn't stop there. Of course, after the power supply has been calibrated, and of course we test our grounds all with our Fluke 179 True RMS multimeter, we then come into the system. I'm trying to move this so you can see the light. Now on the Rev 2 models, you can see the dual power output rails. Now why we're using the dual power output rails, being he's powering this relay at 48 volts, he would need an additional port there, typically because most power supplies that are not designed for CNC use run out of ports because they only have 3. And you're going to see that in the second half of this video. What you see here is a custom design power supply. What you don't see inside of it is it has a built-in EMI filter as well. So with these amount of terminals, you can hook up whatever accessory you'd like to expand this system to, and he won't have to install the required terminal splitter in order to give him the proper amount of power outputs without splitting or daisy chaining terminals together. This keeps everything, once again, really neat. If we look at the chassis, this is a 12 by 12 enclosure. You can see how clean this is. Okay, so again, finishing the system, we have a TDK ferrite installed internally. You can maybe see it. Let's see. Come in right here. And you can see that ferrite right there installed going over the GX16 leads, which once again enter into the G540 filtering all of those connections as they're going in for any signal manipulation going to the VFD. Okay? Sanyo Denki 65 CFM cooling fan, brushless, again rated to 100,000 hours, and it's also 0 to 10,000 RPM in under 2 seconds. Most of you notice that when you turn it on, or again, you listen to my videos and you hear the howl. That's why this fan is very, very high output. That being said, it's designed in an industrial format to cool properly the G540. Let's look at the heat sinks. Something as basic as that. These are all mounted with thermal adhesive. Okay, and that thermal adhesive is conductive in the sense that it's going to transfer heat efficiently from the drive, increasing its surface area, and then all that heat that comes from the drive comes over to the heat sinks, which then helps dissipate it with the proper cooling fan. Okay, once again, the fan is used not to be a component of convenience, so to speak. It's actually used to do a job. That's why it's putting out such output, and that's why it's not designed to be quiet, because this isn't a PC. It's designed to be used in a business environment. So again, you can see exactly what we've got here for the end user. And as far as terminals, everything again is done with solder, heat shrink, and flux, as it should be. And when I say solder, heat shrink, and flux, the solder is Kessler number 44, the flux is Kessler 186 RMA. The system is built as if I would build it for myself. So what you're looking at with the cable, with all of this, all the custom design components, you're looking at a serious investment of, I believe it's over $1,900. And that includes shipping, insurance, and all of that. So when you factor all of this in, and now we look at what people are selling in the used category, and of course this system does include a 3-year US warranty on the drive itself. through Gecko Drive. They will repair or refurbish the drive based on no end user damage for a length of 3 years. You've got what I feel is the most beneficial package if you're serious about getting into the CNC genre, hopefully to make money. If you're doing it just as a hobby, either way, this I would consider a very, very serious hobbyist system, okay? But everything is here for the end user, meaning it's all configured, it's all set up. Support will be sent, once again, in a direct formulation of an email with videos and whatever else is included. Now what I'm going to do is show you and discuss what's being offered in the $300 to $400 price range used with a system, what people are claiming to be similar. And when you guys see this, I think you'll see my point of being facetious. There's a big difference. Okay guys, in this portion of the video, we're going to be taking a look at some used systems that I've gotten questions on from potential clients as far as recommendations of what to do to rectify what I'm seeing with some of these used G540 systems. Now, these questions come up a lot. And doing in comparison retrospect of what we usually see in terms of, again, someone who's lacking the ability, so to speak, of actually assembling a system in the right format using best practice to assure the proper stability that these systems can attain, we're going to look at this in depth because we actually have two systems to look at. I'm not going to disclose naturally the sellers. This is not a beatdown video. It's simply to show what you guys should be looking for and what to expect if you take the leap, so to speak, and purchase a used system and understand what risks are involved and also the positives. I mean, naturally, there are some positives. There's naturally a lot of money to be saved, but at what cost on the opposite end? So let's look at this one. Again, we've got an enable button on the front, e-stop. I get a lot of guys that will say these enclosures look like mine. They do look like mine, but they are not mine. And we'll go over that in more detail as we go through. You can see here the rear fan. We do have some holes that are punched out naturally, not filled in. You can see right here, right here. And again, guys, this sounds technical. It's not technical. In a shop environment, anybody running one of these systems will tell you your system will naturally pick up dust from anything around it. If you have open ports, you're going to pick up even more dust, and that internal dust inside the power supply, inside the drop, over time can cause a lot of problems. It also creates a fire hazard if you're working with flammable materials like wood. So again, be very careful with that. Keep the system clean. Let's keep going. Okay, this is where things start to really come to life. Once again, we can see the open ports. This is where we start seeing issues. We have another power supply mounted over a power supply. We could see some crazy wiring going on. We see tandem leads going into an e-stop. Right here we can see that this area going to the, I believe it's an enable button on the front of the chassis, this is soldered without any insulation. Let's see what we have as we go through this. And as we come in here, once again, we can see the rat's nest of wiring. Over here we can see that we have two leads going into one terminal. Now, on the first portion of the video I posted, I discussed with you why it came out with the dual 10-point output terminals for V negative and V positive, and this is why. These individuals realize that they're running out of lead terminals in order to insert expansion ports from the drive into the power supply. So what did they do? They decide to install lead into a V negative or V positive terminal. In this case, I believe it's V positive because that's a red lead. We'll give them the benefit of the doubt. And being this terminal is only made to support one wire, he then goes on the opposite side and inserts another wire. So again, daisy chaining then starts to become done, and again, it's just to save time with no relevancy to best practice of how to assemble the system. In best practice, we would use a terminal splitter, or we'd use the power supply that I designed, once again eliminating that problem from the get-go and eliminating the labor of installing a terminal splitter. So again, as we come over here, we can see, I believe this is a 24-volt power supply. Not sure exactly what this is powering, potentially a relay. We can come over here, and as we pan up, and we can see more terminals that are soldered without any insulation done here at all. So again, guys, very, very poorly built in terms of safety, and I cannot emphasize that enough. If we're not even using heat shrink on our terminals that are soldered, dealing with 110 volt AC in, we're going to have some serious issues that are potentially there, especially when we deal with an aluminum enclosure. And again, this enclosure is fully conductive, so we got to be careful with that. Okay. One of the biggest things I want you guys who are thinking about getting involved with used systems to worry about. Okay, first of all, we see he's got a fan here. He's got no heat sinks on the G540. So by not expanding the G540 surface area, you're really only going to get limited cooling effect. In this actual mounting pattern, actually it's opposite. He's got the fan blowing air in. So realistically, if you were to not mount heat sinks on the 540, optimally you'd have the fan blowing air out. And this way you vacuum out all of the hot stagnant air. But either way, optimally, just like a PC, you'd have a heat sink on the processor and then a fan to cool those heat sinks, because once again we've utilized a larger surface area giving you better cooling, and then of course using the fan to actually dissipate the heat even more so. That's the right way to do it, done in whatever format he decided to go with, but again, not best practice overall for the driver longevity of components. So again, we look at this, we see the solder connections that are not insulated. What I want to discuss here is something that's seldom looked at by people looking just to save money or just at the dollar amount they're spending. And that is, if you purchase this with this rat's nest, unless you are confident, extremely confident you understand the electronics enough to rebuild this system, where do you begin with this? You're going to go back and trace every wire using diagrams, if you understand diagrams, understand the grounding process, and go in and do all of the work, again, that was supposed to be bought the first time when you bought the used system, if it was done correctly. This is what I want to ask you, because what you're looking at here is a complete mess. And anybody that's been in electronics will tell you, I mean, we see leads not even fully inserted in the terminal block. And then, of course, here, we don't know what gauge wire he's using. We don't know what's connected to what's not connected properly. We see no grounds or shields or anything going on in this system. So my biggest question to you, and this is the thing I deal with most on my business end, is sales are only probably maybe a fifth of my business. The remaining portion of my business is support. I have sold so many drives, so many systems in bare bone format, in driver format, in kit format, DIY kit format. The majority of my time is spent with support. And that's why I did videos, because I leverage my time through the videos, because I can't be everywhere at once, but if I can make my knowledge public, then it makes it much easier on me. Well, I'm asking you this in terms of, as a potential second-hand buyer of a system like this, how would you get support for something like this? We already see massive mistakes here as we go through, and we're not even all the way through the system, but I'm just curious, are you going to ask this gentleman how to wire this? What he did? Because it's kind of like a moot point. If this person is inadequate to build the system from the beginning, why you'd go back to him for more knowledge if it's not there to begin with? I mean, he's defining his knowledge by the build he's actually put forward, and of course he's selling. So I ask that question a lot, and I usually, to potential clients that don't think that far ahead, I never get an answer. And it's a really scary question, because you have to think in terms of, do you understand this system at a level that you're okay saying, I engineered my own system? If you're not able to do that, then you better take into account the investment you're about to make. Because I'll tell you right now, this system that I believe he wants $400 for, you find out really quick, why is it $400? Well, now we see it. Let's keep going. Once again, we got an enable button on the front, power, e-stop, and I believe these are all his pictures on this particular system. So again, just looking at this unit internally, and this is probably the best picture to really review closely. I hope anybody looking at this, and anybody lucky enough to find this video before purchasing this system, realizes what they're getting involved with. And that's the only thing I hope. And why I say that is, if somebody looks at this and says, yeah, that's me, in my eyes, they should have the confidence to say, I need to understand what's involved with me going through this system to make sure I get the best
most stable system possible with the components I'm buying. The thing that scares me and is most irritating as a vendor is that a lot of times guys will buy a system like this and assume that the G540, if it gives them issues, is the problem. They'll assume a lot. They'll say, oh, I connected this, I'm getting problems. Oh, I connected that, I'm getting problems. Oh, I tried what you said, I'm getting problems. But then I see the pictures of the system, and we get a whole different image. And again, the beauty of being in this field as long as I have, if you tell me you can solder, and I say I'm looking for someone to solder, I'm not going to ask you to fill out a resume. I'm not going to ask you, arbitrary questions. I'm going to hand you a soldering iron, and I'm going to hand you soldering flux, and I'm going to say, show me. And if I don't see it match the way it's supposed to look, guess what? You're fired. It's that simple. And that's the way I look at things. I look at things from a logical perspective. This to me is simply logical. Okay, here's the next one. And this one, again, is interesting. You can see here that we've got some motor cables that, and I love seeing this because this tells me a lot. Guys that have computer backgrounds usually look at these type of cables and they say, hey, you know what, I'm going to put sheaths around them like what's done inside of gaming PC cases. And these are the same type of sheath. It's like almost like a yarn or a heavy-duty twine that they put together to make the leads look nice and complete. Okay, and when I see this, it already tells me that we're lacking real competence of what we're working with here. This is not a PC now we're working with. We're not trying to make these leads really pretty. If anybody tried to run these cables with these guards around them, these twines, you're going to find inside a cable chain you're going to have a lot of problems. So that already tells me this is not best practice. As we move forward, this is where things get interesting. He's got limits right here. He's got a spindle plug down here. He's got an ESS mounted in the chassis. And then over here, we've got the IEC and we've got our auxiliary in, and it's invertedly mounted. It's interesting. But let's talk about the limits in the spindle. And many of you guys are already looking and you've watched my channel already and you know what I'm going to say. For those that don't, just get involved. I'm hoping I'm touching base with you real quick. Limits, he has 4 pins, a 4-pin GX16. There are 4 inputs on a G540. Hypothetically, let's say he's using all 4 inputs, okay, for 4 limit switches, 4 home switches, whatever it may be arbitrarily. If he's doing that, where's the shield drain go to if there's only 4 pins, guys? Does anybody know? I know what you're saying. It doesn't go anywhere because there's no shield drain. It's impossible. What about the spindle here? He's got 4 pins here. How is he connecting his spindle controls with 4 pins? You guys saw the previous video where I used 6-pin. 6-pin is simple. You've got all of your inputs from the G540 in terms of the 3 for VFD controls as far as speed manipulation. You have 2 more connections that are required for your relay to cycle it on and off. And then you have 1 more connection, and that 1 connection is probably the most important, which is your shield drain. Okay, that's why we use a 6-pin connector. Okay, he has 4. Once again, to a novice, he wouldn't know. He thinks everything here looks great. Okay, being he's got the ESS mounted inside the chassis, he's got the ribbon cable bent. Anybody dealing with PCs know you don't bend around a 90-degree bend. We don't do that in best practice. Ribbon cables are supposed to have soft bends so they can transfer data properly. When you have them bent in a very, very obtrusive manner, you're going to potentially have data loss. So again, very, very careful with these type of cables. Let's go inside the system now and take a peek. Okay, here's where things really get nasty. Okay, some things are so outrageous I can't make this up. We have heat sinks mounted to the Gecko, and this is interesting because the G540, you can see it stops right here. He mounted 4 heat sinks on the unit that actually protrude past the side of the G540's case. So I'm asking you guys now, if these are hypothetical, I'll give him the benefit of the doubt. Maybe he used thermal adhesive. And if he did in best practice, because that's the best way to transfer heat from the drive itself to the heat sinks, how do you get the drive out? If these are wider than the actual cutout on the back plate? I'm just curious. Okay, these are just logical questions. Okay, you don't need to understand CNC to really see where I'm going with this. I'm not making this up. These are real listings. I get asked that a lot. Here we've got a terminal block being used, and yet he's using a terminal block. I'm giving him the benefit of the doubt not to actually daisy chain, yet he's still connecting 2 leads to outputs on the terminal block, which makes no sense. He's got an EMI filter down here. We'll see that more as we go through, which again, just judging from the rest of this system and as we pan up, we can see even more problems with this 5-volt power supply. We've got 2 leads here connected, 2 leads here connected. I mean, this is terrifying. Then look at the proximity of this power supply here, which again is the largest power supply powering a G540, and he's got soldered leads that are not heat shrunk. Well, look at the proximity of this power supply to those switches inputs. I mean, realistically, this is terrifying. I mean, that's an AC side for that switch. If that metal arcs at all, for whatever reason, the switch comes loose. Maybe the guy goes to press the switch in, and maybe the nylon actual ports on the switch, as far as the supports, something gives. Anything, you could arc off that and instantly have a dead short. I mean, this is scary. It is really, really scary. We also see he installed a relay board. And I'm assuming this connects somewhere or connects to the G540 directly. I am not exactly certain how this goes. I see power coming in from the actual 5-volt. Then we have a cooling fan here, and this is actually really interesting. Let's take a look at this in the next picture. We have a cooling fan. Many of you know that the rear of power supplies typically have a fan installed in them. And what that fan does, you can see the notice right here. The fan will kick on to evacuate hot air from the power supply. Well, that air comes out right here. He's got the fan basically taking in the exhaust air from that power supply and blowing it right over the heat sinks of the G540. I can't make this up. So again, this is once again what you're comparing to in terms of price. I want you guys to look at this. It's treacherous to me to think what's going to happen when somebody purchases a system like this and they hope for the best and God only knows if it's working. And as we go through here, we can see the spaghetti wiring. He's got a ground over here. It looks like there's a couple grounds. I don't know what's going on there, but he's got a couple grounds right there. And as we come over here, once again, we see the power supply and multiple leads going to terminals. I mean, this is scary, guys. It's really frightening. And I'm telling you right now, the Ethernet Smooth Stepper is literally one of the most stable controllers out. However, and you can contact Warp 9 about this if you don't believe me, most of the issues that are caused by symptoms like this, where guys will say randomly, oh, I'm getting random issues with the system. Well, if you install a 5-volt power supply that's powering this ESS, and we're in this proximity in here, and all this other stuff is going on inside here, and all that EMI is trapped in here because, again, this power supply, as far as the EMI that radiates out of this, and then this power supply here, plus I'm believing this is a buck converter of some sort. I'm guessing. I don't know. But let's just give him the benefit of the doubt and say it is. And even though this EMI filter's over here, he's not filtering out all these power coming in here as far as what's being dispersed to the G540. All of that EMI is going to be coagulated around that ESS. That's why I sell a turnkey package where the ESS is separate from the system. 2 reasons. First of all, it mitigates EMI because it's not inside your system. Second, most important, try troubleshooting this system. Once again, where are you going to go with this? Are we going to start tracking down all the leads? Is there any labeling here? X yellow, Y brown, Z green? I'm drawing a blank, guys. This is what you better be ready for if you're buying used. And I'm telling you that because I get more and more guys coming back to me after they buy. They find my videos after they buy, and then they're hit over the head with a price, and they feel like, oh my God, What do I do now? Now I've already spent this. Now I have to pay this to get this right. I don't want that to happen to you. Do it right the first time. Save, or only borrow if you understand the gravity of what you're doing to leverage from. And when I say that, if you really have a business model that somebody is saying, hey, you know what, I trust you, I'm going to give you the money to do this, let's put together a plan for you to start paying things back and get set up, God bless you, that's the way to go. Before buying something like this and basically starting over. Let me tell you my theory on how someone should sell a system like this, because I got asked this too. Vin, what would you do if you were in their position and you didn't understand the build characteristics of a system? How would I sell this? Let me tell you how I would sell it. I would dismantle everything, clean everything, and I would sell it in pieces. Couple reasons. First of all, you're going to get more money usually selling components individually. It's more work, you'll get more money. But the best part about doing it that way is you're not putting anyone else at risk. You don't know what's going to happen with this switch in proximity to that metal enclosed power supply. Okay? I would much rather sleep well at night knowing that safety is not an issue than selling something to someone just to get it off my hands and hope for the best. Okay? Because even though these are eBay purchases, these are treachery in terms of what an end user will go through to potentially even trace a wire down. I mean, where are you going with this? I mean, understand what you're investing in. Take your time and make sense of it. Because a lot of this stuff is logic. If it doesn't look right, if it doesn't smell right, it's not right. And that's why I tell you guys, take your time, take a step back, ask questions. And I just did a consultation this week with a gentleman from Australia. We set up a time, and it was like a $60 consultation. We went over his whole system build. It wasn't a G540 he was working with. He was working with drives I don't supply in terms of offering in my store. And he had some general questions. And I brought up something that I haven't said, but I'm going to start saying it because it's absolutely true. Actually, he agreed with me on it, is that he made a mistake the first time. He started watching my videos, and he's like, wow, I tested a lot of what you said, and I didn't even contact you yet. I just tested what you said in the videos, and you were right. And then all of a sudden, it was like, hey, let's move forward. Well, I hope a lot of you do that. Don't take me on my word. Check what I'm saying. See if what I'm saying is accurate. Okay, you can check my feedback. It's open. I'm not trying to hide anything. I'm being as transparent with you as possible. The big thing you need to realize is this. If you make a mistake with buying something like this and you don't know what you're doing, that mistake is going to cost you a hell of a lot more than a $60 consultation before you buy it. And if you don't believe me on that, ask anyone in the field. Anybody who's dealt with CNC, or just do a YouTube search, you'll find guys that are dropping cash after cash on different things to rectify different problems when it could all be solved instantly. Now, the prices on both the systems I just showed you, one was, I believe, $350, one was like $400. One is already sold. It already has a bid on it. I'm going to say, if you look in this system, you don't see anything with grounds other than these two over here, and we see no shield drains, no signals are being properly double shielded as far as cabling, no ferrite installs, other than this EMI filter over here, which, again, we have no idea where that's actually going. I'm assuming it's just covering the power coming into the system. I don't know. I'm going to tell you a real easy way to know if you want to question a seller if the knowledge is there correctly. Just ask him to show you the shield drains from all the inputs and outputs that you're using. Okay? I've gotten asked that numerous times, and I love that question because I want you guys to see where they are so you understand it. That's why on the previous system, earlier in the first portion of the video, I showed you on my system where the ground bus is. And that's exactly why. The E-stops in my system also use tin-braided copper shielding, and I build those. I actually did a video showing you how I build them, where I use 20-gauge silicone leads. Again, there's no current going through them. It's breaking a ground. And it goes right back, and we use tin-braided copper with heat shrink over it, solder a lead to it with a ring connector, and that goes right to the base of the power supply, which, of course, my chassis have full continuity as far as ground. So you're all set with that. Where do you see any of that with this? It's like I said with the previous system, the most upsetting thing, and this isn't just for me, it's for all vendors, is that they'll get a bad rap and they'll say, hey, I'm having trouble with the G540, I'm having trouble with this or this component, or the ESS isn't functioning right. Is it really the ESS in this case, guys? Is it the G540 in this case? Or is it incompetence on the end user trying to build a contraption that doesn't even resemble what he's actually trying to do? I mean, you have to look at this from all angles. And then to pass it on to someone else, even if the price is ridiculously low, and we're looking at safety right here, where do you go with this? I mean, that's the real question. I'm curious what you think. Because I look at this and to me, I always find it wrong. This is terrifying. And I say that openly because I know many of you look at these systems, you see the price, and to a novice, they jump on it. Jump on it if, once again, you understand what you're getting involved with. Do not jump on it and expect to contact this individual who's selling it to you and expect him to give you support, enabling him to provide you with best practice. Because if you look at this and think any of this system is best practice, look at other systems. Look at the video I'm providing. I hope many of you find it before purchasing. Okay, and even if you don't purchase from me, you can call Marcus at Gecko. He's been a direct reference of mine for a while. If you have any questions, check out what I'm saying. Check this out. Send this to him. Let him look at it. You know, ask the questions that should be asked before spending your money, and make sure your money is safe. That's the big thing. My lead times, unfortunately, have grown, and it's a positive negative thing. It's a quality thing. I won't release a system that I wouldn't use myself, number one. And number two, my clients are, you know, right now they're in high demand due to the fact that they're dealing with a lot more infrastructure increase as far as the robots they're using. Once they find out these systems work, they keep buying them. And it's that simple. Many of you do the same thing. So again, my lead time is one man. I have to increase my lead time. It just is what it is. But I would rather make you wait than sell you something like this. So again, guys, I hope that this video has been helpful. I like seeing a direct comparison between G540 systems because I sell so many of them. I get asked so many questions on them. There's so many variables with them. Even though they're a basic integrated drive system, there's still tons of options. Again, dealing with the master system enclosure, and then dealing again when we're dealing with, you know, options to add VFDs and options to add switches if you want them. Even though I still recommend using soft limits first before going that, you know, taking that deep dive into that investment and the headache of dealing with, you know, building the cables and whatnot, if that's what you plan on doing. Look at your big picture first. Look at why is a system that much money. Look at the resources, look at the references, ask to look under the hood, ask for the, like I said, grounding. I want to see your grounding practice. You know, if you ask this guy, you say, well, where's your ground bus? Where's any of the actual input grounds? You have inputs going out for switches, you have a 4-port pin. How is it possible to have a 4-pin GX16 on your inputs when we know that the G540 itself requires 4 leads individually just to control the inputs on each axis? So that means where's the second lead? I mean, you're going to need a second lead going to the power supply. On top of that, you're also going to need a ground drain. So where is all this stuff? If it's not there, what's going on, guys? Ask the questions. Ask the questions, save your money, and save yourself some headaches. So again, guys, I hope that this video was short enough to cover at least in detail how I can at least help one of you save money. I know it's going to reach out to at least one in terms of making sense, and they'll think before they leave. Be careful. Once again, if you require consultations, quotes, or you have any questions, message me direct at storm2313@gmail.com. I'll do my best to answer you as soon as possible. Right now, of course, things are kind of crazy in the shop, but I will get back to you as soon as possible. Once again, you can see the links in the beginning of the video and at the end. I thank you all for your support. Take care.